Hello everyone, my name is Erwin Heyms and this is my entry for the SideFx LABS 2001 Tech Art Challenge. I'd like to introduce you to the PolySlice utility node. This is a node that's able to cut new edges and points into geometry procedurally based on a secondary input, and it does so while maintaining all groups and attributes already present on our input geometry. So over here I have a source mesh, in this case a rubber toy, and I have some cutting planes, and they're intersecting the mesh, right? So I feed those to the PolySlice, and as a result it cuts up the mesh, and in this case it's also cusping all of the edges, so when I output this I can also explode it. Now this isn't the only type of cutting behavior that this node can do. Up here you can see we have several options available, and that includes different types of cutting geometry such as points, polylines and polygon surfaces. And we can also apply this to polylines exclusively. So besides that and the other settings, let me quickly show you some of the other results that you can apply using this node. Now included with my entry is an example file which will demonstrate various types of uses and also how this node compares to the other cutting utilities already present in Houdini. Now over here I have a couple of examples of the vanilla cutting nodes that are already present in Houdini. And oftentimes when I try to take, for example, a box and I try to cut it with a plane, with a Boolean node, it will create an internal piece of geometry, right? In that case I would have to remove that piece of geometry. In other cases, for example with the intersect stitch, if I try to cut two pieces of geometry together, such as here, I get unpredictable triangulation, and that can cause issues as well. So oftentimes when I try to do something with the existing nodes in Houdini, I have to jump through hoops to make it work. And that is assuming that they will actually function as I expect them to and not break. And with that what I mean is that if you take these nodes and you put them in certain situations, they often break. The Boolean node, for example, cannot deal with coincident faces, so surfaces that are right on top of one another, when they are not in a cardinal angle. Likewise, over here, if I try to cut this plane with this edge, unlike on the left here, where I have the same setup but in a planar level, flat on the ground, the moment you turn this plane on its side, the precision of the node is no longer working, and it doesn't actually cut the plane. And if I go along these examples, you'll often see that in a lot of cases the nodes work in some way or form, but if I push them or if I set them up in the wrong way, it breaks and it creates bad geometry. So in the end, what I did is analyze these existing nodes, I found their strengths and their weaknesses, and I combined them into a new node I call the polygon slice. So the PolySlice is able to take our geometry and reliably and predictably cut it using a variety of settings up here. We can also configure our precision and our snapping behavior. So we can actually snap our geometry, like for example over here. I can provide a couple of different curves that aren't exactly on my geometry, but as long as they are nearby, they will cut the geometry reliably. For example, if I move this curve around, you'll notice that it does cut the geometry. If I move it away from the edge, it will try to make a connection unless I tell the node not to. So if I prevent incomplete slices, it will not allow that cut. And the PolySlice always tries to make a complete cut, so it doesn't end an edge in the middle of a primitive, creating a very awkward polygon. Likewise, all the other cuts are all connected together unless you turn on cusp cut edges, in which case it will split them up. So we have a lot of control there. Furthermore, the snapping behavior also extends to this cutting here. I can take one grid, put it on top of the other one, and based on where this is located, it will snap to the edge and create a clean cut across, even if the meshes aren't quite perfectly on top of one another, like in this case. Now, as for what this node can be used for, let's quickly have a look at some practical examples. Over here I have some of my examples set up, and over here I have a floor plan created with a simple curve node, So I've just drawn a simple floor plan with a curve, and then I have another curve which describes a corridor. I overlay those two, turn on the node, and at the end it will create a new cut into my geometry that is clean, like this. And it will also add edges to the ends that describe them as corridor walls. I can then group this corridor, and then I can feed it to the next node, which has a couple of other cuts that it will try to make across the geometry to create rooms. So in this case, I do not want to cut my corridor, but I do want to cut the rooms. So I've basically created a group here and excluded that cut over here in the node, so it only creates cuts on the outside. And if I color that, and I make sure that I actually cusp my edges, for example, then you can see that it properly has separated all of the different parts of my geometry. But if I don't do that, it won't. Then, in this case, I'm also creating a new edge group for my cuts for the walls for the interior. Looking further down, we have this next node, which will inject a couple of support columns into our walls. In this case, I'm using a couple of simple points that are on top of my mesh, these yellow points here, and also a point that has been grouped called no cut. So in this case, I'm excluding the no cut point, but it's still cutting everywhere else. And then finally, I have a couple of boxes on top of my mesh, these ones, and they are cutting into my walls, creating new cuts where I might want to have a door. So we can apply our cutting behavior in various different ways, and when I say take this result and I apply it onto my mesh, now I have some walls, I have some potential locations where doors could go, and I have my support columns. So with just a couple of quick nodes, I can easily create an entire corridor layout with walls, all pre-cut, and they're all clean and set up properly. So in the end, I get this result. Now there's a couple of other things we can do with this node as well. For example, it has the ability to auto-complete cuts if they are not completed. For example, here I have a line. If I feed that into the node, it will try to complete the actual cut. Let me turn on the cutting view so we can see where the cut's being made. Now if I only want to highlight the actual cut and not the automatic completion of that cut, I can also say avoid grouping incomplete auto slices. Turn that on and it will only group the actual cut. Then I can start layering on top of that a couple of other cuts as well, creating more predictable anchors. And then I can simply grab this and pull it around into whatever shape I need to. So you can easily see how we can quickly cut geometry, and we can use this for greebling. We can use it to cut streets. We can use it to cut, in this case, a cube, and that cube is being diced up. And because it's using curves, and those curves are snapping, we can easily create cuts across our geometry without a problem. And then next, let's have a quick look at this example. Over here I have a couple of splines, and I'm moving a grid across them. So up here I have set the node into taking polylines, and then it cuts them with polygon surfaces. And I'm outputting a cutting group over here. And we can see that visualized on our mesh. Furthermore, on the right, I have a couple of curves that are intersecting one another. And they are able to cut each other as they cross one another using just two nodes. Or we can wrap them inside of a for each loop, process each one against the other, and then output that as a result. Plus it keeps the groups, such as a primitive group and edge groups, intact from the input to the output. So we have full control there. Next to that, over here I have a box with two UV sets, UV1 and UV2. And then I run it through the PolySlice, and in the end we still have all of our UVs available right here. So all of these attributes are maintained and the cuts are made cleanly across the geometry. Now to conclude, I would just like to say that the PolySlice node is a very powerful node. It has a lot of versatile options, but it's also quite intuitive. I think it's very easy to use. You just have to configure what type of geometry you're trying to cut, what type of geometry you're trying to cut it with, and how you want to output it. And then for the rest, you have some groups you can use to filter out what you want to cut. You have settings on how the cuts should work. You can output different groups based on your cuts. And finally, you have precision controls for snapping. And if you want to be even more intricate, you can also play with the tolerances independently as well. So, as a conclusion, I hope that this tool will be added to the SideFx LABS toolset or added to Houdini proper. The node is a little slower than some of the other cutting nodes. As such, it's better for precision tasks. But when it comes to those precision tasks, I think it is very powerful and can do things that no other node in Houdini is able to do without having to jump through about 10 different hoops. So with that, I hope you find this an interesting and useful addition to Houdini, and I await your consideration. Thank you very much.